Hi everyone, you're welcome to DML Physics Concepts. Kindly subscribe to this YouTube channel, like this video, and make comments. And if you have any question, you can just drop your question in the comment section. Thank you for being with us. Now today, we want to continue from where we stopped. We started projectile motion last week and last class, and we look at projection, vertical projection, when the object is projected vertically at a certain angle to the horizontal. And from that class, we're able to deduce the following formula. We are able to deduce that the time to reach maximum height is given as u sine theta over g, while we said the total time of flight, which is 2t. And if t is this, then the total time of flight is 2u sine theta over g. We have also deduced that the maximum height, h, is u square sine square theta over 2g. And finally, we deduce the range, and we'll say range is u square sine 2 theta over g. And that class, we explained how we arrive at this following. We said vertical projection also always have two independent motion, the vertical and the horizontal. And I said the horizontal, for horizontal motion, the acceleration is 0, meaning that the velocity is constant. While for vertical motion, the acceleration is due to gravity, as the object is moving up and moving downward. So today we want to look at the horizontal projection. We want to look at horizontal projection. Good. But before we go further into horizontal projection, so I want you to watch this short video. So watch this short video and look at the motion of the two balls, the one that is projected vertically and the one that is projected horizontally. So after that, then I will continue with the explanation of this class. Thank you for watching this short video. Alright, now what can you see from that video? You will discover that from that video, the two balls was projected at the same time. One was allowed to move vertically downward, while one was projected at a certain velocity. But when you discover that when the two objects moves at the same time, you discover that the two objects lands at the same time. That's why you see that the ball is landing and the sound of the ball is at the same time. It is giving just a sound, showing that the ball is landing at the same time. So which means irrespective of how you project a body horizontally, the acceleration of the body is 0. The object is moving freely under gravity. And that is what we want to look at. And that's why I said the two motion is independent of each other. So let's look at horizontal now. So for horizontal, what we are saying is that this is the axis. So it means the object is projected like this horizontally and it's allowed to land on the floor. So the object is projected horizontally and allowed to land on the floor. So when the object is projected horizontally, so we are going to have two components. But let's look at something here. This is the maximum, this is the height. So if we want to look at the height of fall, the height of fall, this is the height of fall. If I look at this one is the range. That is the time taken, the range is the distance from here to where it hits the ground. This is our range, and all this one has their own formula. So in this case, when an object is projected horizontally, there are two independents, the vertical. So we look at the vertical motion. Let's first consider the vertical motion and deduce certain formula from it. For vertical motion, we look at it as if, more or less as if saying that this object is just dropping freely. And remember, when an object is falling freely, the initial velocity of an object is 0. So we can just recall that when we are looking at our equation of motion under gravity. I want to separate this component into two. The vertical movement. We separate the vertical movement from the horizontal movement. The vertical movement from the horizontal movement. So for the vertical movement, our u, initial velocity, is 0, and then we are going to have our s, is distance, is talking about the height covered, and because the object is moving under gravity, our g is going to be positive. Remember, it's falling directly in line with the gravity. So in that case, let's look at equation of motion to find our height of fall. So our height of fall should be given as we can just use the formula h equals to ut plus half gt squared. That's going to be the formula we are going to use because the object is falling and we want to look for h, and this formula we are going to use. So our h will now be ut. Since u is 0, is 0 multiplied by t plus half gt squared. So it's equal to 0. So in this case, our h is going to be gt squared over 2. So which means when a body is projected horizontally, the formula to find the height of fall of that object is going to be gt squared over 2. So let's find the time. So to find time, just make t subject of the formula in these parameters, and just say t gt squared equals to 2h. So let's make t, then t squared is going to be 2h over g. So let's make t the subject of the formula now. T is going to be the square root of 2h over g. So which means if I say what is the time taken for the object to reach the ground, then we are still saying t is the formula we are going to use, going to be t equals to the square root of 2h over g, because both the time and the height, they are vertical components. So that's why I'm using the same formula to deduce h and deduce t. But let's look at the case of horizontal movement. So when the object is projected horizontally, let me clean this side. Just note that when the object is projected horizontally, there are two independent, the vertical. So we have used the vertical to determine the height, and we have used the vertical to determine the time. So the next thing we want to look at our range, which is our r. So let me clean this side. So now for horizontal projection, so we have our u. There's a u here because there's no angle theta. That's why we are not saying u sin theta or u cos theta. So the object is just horizontal, so it's not projected at certain angle to the horizontal. So we have u here, and remember that as the object is projected horizontally, our acceleration is always 0. Don't forget that concept. In that previous classes we explained that when an object is projected like this, we are going to have an horizontal component. So u is constant. Remember I say u is constant. U is constant, telling us the acceleration is 0. So when the object is projected horizontally, so there is a u component that projects this object horizontally. But this u component is not u sin theta nor u cos theta, because this object is not projected at angle theta to the horizontal. So our u is still u as value. But what's our acceleration? Acceleration is 0. I want to look at the distance, that is the s, the distance covered before it reached the ground. Our s is what we are looking for, which is our r. So in that case, we are going to still use our formula for equation of motion that says s equals to ut plus half at squared. That's the formula we are going to use, whereby our s is r. So our r equals to u. Remember, our u is still our u component. U is there. U is not 0. As the object is launched horizontally, we are looking at it horizontally now. We are not looking at it vertically. That's why I said the vertical motion and the horizontal motion must be correctly distinguished. And that is the main concept of this topic. So that we're able to understand when the object is moving horizontally, the u is not 0. But when the object is moving vertically, when we are looking the object vertically, then u is 0. So by the time we divide the two components to 2, the vertical component will be looking at u as 0, but horizontally we'll be looking at u as the value of u as given. But acceleration will be 0 because this u will be constant along that path. So u, then we have the t plus half. Remember, our acceleration is 0 times our t squared. So whatever our t value is multiplied by 0, everything here becomes 0. So that's why our range equals to ut. So our range equals to ut t. So if our range equals to ut, remember we have gotten, for vertical component, we have gotten value for t, where we say t equals to the square root of 2h over g. If you recall that, we are looking at vertical component. But for horizontal component, we also say that t, if I want to make t, so t here is going to be r over u. So in each case, the time is always the same. Remember, whether the object moves vertically or move horizontally, the time is always the same. So the two objects is going to land at the same time. So the time it will take this object to move horizontally is also the same time it's going to take the same object to drop vertically. So if time equals to time, then we can equate this equation together. So if I equate it together, then we are going to have r over u equals to the square root of 2h over g. If I cross multiply, then r equals to the u, the square root of 2h over g. So which means we can also find our range using this formula or using this formula. So now, for horizontal projection, if anything they're asking you has to do with the height of fall, we are going to use the formula height of floor, h, and what's going to be h? H equals to g t square over 2. If they ask you what is the time, then the time you use t equals to square root 2h over g, or you say t equals to r over u, depending on the parameters that was given in the question. Because the time for vertical is also the time taken for horizontal component of that motion. Thank you for watching this video. In the next class, we'll now start. Next class, we'll apply the concept to solve some calculations in physics. But before we conclude today, I want you to understand that a certain concept. Let me quickly explain this concept before I conclude this class.
Here's an interesting thought experiment. This cannon is ejecting a ball perfectly vertically. The ball will come back to its initial position, or zero movement, in the horizontal direction. Now let's reduce the angle and eject it with the same speed. Now the ball can travel horizontally. With a little more angle reduction, the range increases further. When the cannon's angle is down to 45 degrees, the range becomes even higher. However, if you increase the angle after 45 degrees, the outcome is different. The range actually decreases. The maximum range is at an angle of 45 degrees. Before and after that, the range decreases. Can you guess the reason behind this? The range of the ball is multiplication of the initial horizontal velocity you have given, multiplied by the time duration it stays in the air. The time the ball spends in the air decreases as you decrease the angle. However, the horizontal velocity keeps on increasing as you reduce the angle. Multiplication of two numbers will be maximum when both the factors have a good value. In this case, the time the ball spent in the air and horizontal velocity has a good value at the angle of 45 degrees. This is why you get maximum range when you throw the ball at 45 degrees. With this understanding of projectile motion, it becomes quite easy to solve the question we posed at the beginning of the video. The time it takes for the stone to hit the ground depends only on its vertical velocity. Even if you have given a high horizontal velocity to your stone, its vertical component is 0. This means both the stones have the same vertical component of velocity at the beginning, 0. This velocity will increase over time due to the effect of gravity, but with the same magnitude. This means the vertical component of velocity of both stones is the same throughout their travel. Therefore, both will hit the ground at the same time. Pretty interesting, right? The greater speed you have given to the stone has no effect at all on its travel time because you threw the stone perfectly horizontally. Thank you for watching. We hope you enjoyed the video. See you next time.